On pages 1 and 2 in the equation solving packet, you're going to work on solving 1 and 2 step equations. I'm going to start with some examples from page 1. In page 1, you're going to be solving just one-step equations, meaning there's going to be one step to get to your answer. The general set of directions for all equations is to first start off by drawing the train tracks so you can visually see the two sides of the equation that have to be equal to each other. Second, you're going to go through a series of steps to isolate the variable by working backwards to undo everything that's been done to the variable. It's sort of like reverse order of operations. And last, you'll want to check your answer to make sure it's correct. So in our first example, we're going to draw the train tracks. And our goal is to get the variable by itself. So to get k by itself, I need to get rid of this 4.75, or 4 and 75 hundredths. Right now, that's a positive 4 and 75 hundredths. So to get rid of it, to get it to be 0, I want to subtract 4 and 75 hundredths from both sides. With decimals, you want to make sure to remember to line up the decimal point. Now actually, on this problem, since we're taking away a bigger number from a smaller number, we're going to want to change that to adding the opposite, and then we're actually going to have to stack these up the other way, and I'm going to just do that right over here. Put the big number on top, the small one on the bottom, and subtract 4.75 minus 2.5. 5 take away 0 is 5. 7 take away 5 is 2. Bring the decimal straight down. 4 take away 2 is 2. And then you want to keep the sign of the number that has the greater absolute value. So it's going to be negative 2.25. And on this side, this is going to disappear, and you'll have k equals a negative 2.25. Negative 2 and 25 hundredths. Now to check your work, you can take your answer and plug it back in for the variable and see if it's true. You'll want to check if 4.75 plus a negative 2.25 is equal to 2.5. Let me check that out real quick. All right, I did a calculation and it did work out. Next problem. Draw your train tracks. You want to get the variable by itself. So to get j by itself, you want to get rid of this minus 87 or negative 87. To undo the subtracting of 87, you want to use the inverse operation and add 87 to both sides. Negative 87 plus 87 is 0, so that's going to be gone, and you're left with a j on the left. And on the right side, negative 3 plus 87, those are different signs, so you're going to find the difference between the two numbers and keep the sign of the number with the greater absolute value, so it's going to be positive. J equals 84. Now again, to check your work, you plug this back in, your answer back in for the variable. 84 take away 87 does equal negative 3, so we know we have the correct answer. This next one has something in it that might trick you, so pay close attention. If we want to get m by itself, we need to get rid of this 8. To get rid of a positive 8, you want to subtract 8 from both sides. When I subtract 8, the 8 will disappear on the left, but I'm not left with m, I'm left with negative m, or a negative 1m. And on the other side, 17 take away 8 is 9. Now at this point, you think you're done, but you're not quite because it's a negative m, and we want to know what m is. So you'll either want to multiply both sides by a negative 1 or divide both sides by a negative 1 to get rid of that negative in front of the variable. And you end up with m equals negative 9. Now to check your work on this one, you'll plug that back in, and it's 8 minus negative 9 should equal 17. 8 minus a negative 9 is really 8 plus a positive 9, which is 17, and therefore it checks out. We know we have the correct answer. Those were all addition and subtraction problems. Next, we're going to try a couple multiplication and division problems. In the first example, negative 3p means negative 3 times p, and to undo multiplication, you're going to want to divide. And our goal is to end up having 1p here. So we want to divide by the coefficient of p, which is negative 3, and we want to make sure we do the same thing on both sides. Negative 3 divided by negative 3 is a positive 1, and 1 times p is just p. On the other side, negative 36 divided by negative 3, that's going to be a positive 12, since a negative divided by a negative is positive. If you want to check to make sure you're right, plug that back in. Negative 3 times 12 is negative 36, which is what we have on the other side, so we know we have the correct answer. This next example, the equation is x divided by 12. That's what the fraction bar means as far as the operation. It's x divided by 12. To undo dividing, you want to multiply both sides by 12. Because if you take something and divide it by 12 and then turn around and multiply it by 12, you're back to what you started with, which was x. So these 12s will end up canceling and becoming 1s, and 1 times x is x. And on the other side, 3 times 12 is 36. To check your work, you take and plug 36 back in for x. 36 divided by 12 is 3. Therefore, we have the correct answer. The last example is a little bit tricky. If you have a fraction times a variable and you want that to be a 1g instead of 3/5 g, the quickest way to get rid of that fraction is to multiply it by its reciprocal. Because if I go ahead and multiply it by its reciprocal, the 3's will become 1's, the 5's will become 1's, and 1 times 1 is just 1, and 1 times g is just g. So we've got it to be 1g, but we have to make sure we do the exact same thing on the other side. So multiply that side by 5/3. Negative 6 times negative 5/3. I know it's going to be negative because a negative times a positive will always be negative. And then you can either multiply across the top and get 30, and on the bottom 1 times 3 and get 3, and 30 over 3 can be simplified. Or you can simplify ahead of time because 3 goes into 3 one time and it goes into 6 two times. And then you can just multiply across the top. 2 times 5 is 10. And 1 times 1 is 1. And 10 over 1 is just 10, and it was negative, so g equals negative 10. To check your work, you would plug this back in. 3/5 times a negative 10. Again, you can simplify ahead of time. 5 goes into 5 once, 5 goes into 10 twice. And you end up with 3 times a negative 2, which is negative 6, over 1 times 1, which is 1. And that's what we started with over on the right-hand side, was negative 6. So we have that one correct as well. In order for you to get this first page of your packet checked off, your work needs to look exactly like mine. I should see train tracks, I should see adding to both sides, subtracting from both sides, multiplying both sides, or dividing both sides. And if you want to not have to redo, you might want to make sure you check your work before you bring it up to me. Page 2 is going to use the same process, except for now it has 2 steps instead of 1. So we're going to start out by drawing the train tracks, and then we're going to isolate the variable by working backwards to undo everything that's been done to the variable. Right now, what's been done to the x is we've multiplied it by 8, and then we take 2 away from it. So if we want to work backwards to undo that, the first thing we're going to undo is the minus 2. We're going to undo minus 2 by adding 2 to both sides. Negative 2 plus 2 is 0. So on the left side, we're left with 8x, and on the right side, 0 plus 2 is 2. Now, the second thing we're going to undo is the multiplying by 8. To undo multiplying by 8, we're going to divide by 8. Because remember, our goal is to get 1x. And 8 divided by 8 is 1, and 1 times x is x. On the other side, 2/8 is 1/4 or 25/100. If you want to check your work, you plug this back in for x. 8 times 1/4 or 1/4 of 8 is 2, and 2 take away 2 is 0. We've got the correct answer. The last example, draw your train tracks. Again, we want to work backwards to undo everything that's been done to x. So right now what's been done to x is we've multiplied by 3, and then we took away 26. So to undo that, we're going to work backwards and undo the minus 26 first by doing the opposite or inverse operation. We're going to add 26 to both sides. 13 plus 26 is 39. And on the right side, the negative 26 plus 26 disappears because that's 0, and you're left with 3x. The last thing we need to undo is this multiplying by 3 by dividing by 3. 3 divided by 3 is 1. 1 times x is just x. And on the other side, 39 divided by 3 is 13. To check your work, you would go put this back in here. 3 times 13, take away 26, and that should work out to be 13. So we have the correct answer there as well, because 39 take away 26 is 13.